Now in this video, we will try to clarify our understanding of how to delete a node in binary search tree. Now before going to the actual delete operation, let me tell you one thing. Whenever you will modify a data structure, either insertion or deletion or whatever modification operation you do, always remember the resultant data structure should also follow the restriction of that data structure. Meaning, if you delete a node in the binary search tree, make sure the resultant tree or the outcome should also be a binary search tree. Now, in order to do that, there are a little bit complication arises during the delete operation. It is not as straightforward as our insertion operation. So what are the complications that we are going to clarify in this video, and we will see how to resolve them. So now before going to the delete operation, again remember the properties of the binary search tree, which is left is less than parent, which is again less than right. Now in a binary search tree, there can be three different type of situations in the context of deleting a node. First situation is if you want to delete a node that has no children, that is if it is a leaf node. In that case, what you can do is you can simply delete the node without taking care of anything because it has nothing underneath. So you can freely delete it. There is no problem in that. The second situation is if there is one child like this of this node. Let's say you want to delete 72, and so how can you do that? Because 72 has a right child, one child in here. In that case also is very simple. In that case, what you need to do is instead of pointing to the 72, you just need to change the pointer over here. Instead of going through 72, you can just directly replace the link from 91 to 90, and that will take care of it. And well, for replacing that link, what you can easily do is you can just in this example, what will happen, let's say if you say that this is the node where which one you want to delete. So let's say this denotes the node 91. So what you have to do is, so this dot left child, so this dot left should be changed because 72 will be deleted. So this should be deleted and this should change as this dot left dot right in this case. So basically you just replaced the 72 with its child, with its right child, that is 90, and you are done with the deletion. So that is also easy. The major complication arises when the node that you want to delete has both the children. Let's say a node like 65 you want to delete. What can you do in that case? If you just delete this node, everything will be a mess. You cannot just delete, because if you just break the node in here, everything afterwards under this node will get lost. So you cannot do like that. Also, which one should you replace? In case of only one child, we can easily replace with the next with the child node of the node that you wanted to delete. But here you cannot do that. Which one should you pick, 50 or 91? Well, another level of complication. You cannot pick 50 and 91. It's not even that simple, because if you just pick either 50 or 91, the property of binary search tree, that is L, P and R, that will be messed up. For example, let's say you pick 50 and you just, after deleting, so here after deleting 65, you just replace it with 50. Just see what happens. Here it is 50, and then in the left child of 50 there will be 55. So, and all the things are pretty much messed up. The same thing will happen if you just, instead of let's say 50, if you replace it with 91, then also several problem will happen, like 91 will appear here, but on the other hand, where will you put 72? Because 72 must be in the left hand side of 91. So these are the different things that comes into picture when you want to delete a node which has two different links, I mean, or both left and right child. So in that time, actually what you have to do, you have to replace this node, the node that you want to delete, which is 65 in our case, with its immediate predecessor, which is 55, or with the immediate successor of 65, which is in our case 72. So instead of replacing it with the immediate child of 65, we just need to replace it with either its immediate predecessor or its immediate successor, that is either 55 or 72. And now if you replace it with immediate predecessor or successor, then you will see that the binary search tree property will hold true, because immediate predecessor means it is appearing right before 65. So if you just put 55 here, that means instead of 91 in here, so let me just clear this. So if you just put 55, now what you can see, that all the elements in the left hand side are less than 55, 50, 46, 47, and all the elements in the right hand side, that is 91, 72, 99, 90, everything is greater than 55. So that you can do. Also, instead of 55, if you choose, so this is one option. Also, if you choose to replace this with 72 in here, that is also possible. So by putting 72 in here, you can easily see that all the elements in the left hand side are less than 72. On the other hand, all the elements in the right hand side, if you do it, they are also less than, they are greater than 72. So either replace with predecessor or replace with successor if you want to delete a node in a binary search tree which has both the children, that is left and right, present.